In this video, we are going to see about some of the op-amp circuits, that is operational amplifiers. So first we see the operational amplifier. So this is the symbol of operational amplifier. From the name itself we can see the input is amplified. That is, the magnitude is increased. So here in the symbol there are two terminals, input terminals, inverting input terminal and non-inverting input terminals, and only one output terminal, and then two power supply terminals, this V plus and V minus. So inverting input terminal, that means connected to minus. So negative sign, that is inverting. So plus means it is a non-inverting input terminal, and then this is the output terminal, we got the output. Here V plus V minus, in order to process this IC, this op-amp, we need an external DC source. So for that, at plus or minus 12 volt is connected here. And now this is the IC, this op-amp IC741 op-amp circuit. Here number of pins are 8. For example, we have taken the 741 op-amp. Here in the 741 op-amp, the first pin is connected as a null connection. The second pin is used as an inverting input terminal, that is minus. And the third pin is the non-inverting input terminal. And the fourth one is the power supply V minus. And the seventh one is the power supply V plus. Sixth terminal is the output terminal. And fifth is also the null connection. In eighth also no connection is connected. And now next move on to inverting amplifier. So inverting amplifier, the output you are getting is an inverted input, that is the inverting amplifier. Here V in is the input, V out is the output. So here V out is the inverted input V in. So in order to get that, the V in, that is the source voltage, is connected to minus. Here we need inverting output, so connect to inverting input terminal minus. Here the feedback resistance R2 is present. Keep the non-inverted input terminal as ground. So here suppose if you are giving any sinusoidal voltage, means here in the output you will get the inverted sinusoidal voltage with the amplification. So inverting amplifier is one in which the output is exactly 180 degree out of phase. That means here you see we are giving the input voltage of magnitude 1 volt. And now in the output you see it is inverting. Here it is started from 0 to 1, but here it is started from 0 and then again to minus. So that is inverted. Here the magnitude is 1 volt, here it is 2 volts, that is amplification. This amplification data, this one is amplified to twice. Here the gain is twice. If the input is 1 volt, means here the output magnitude is 2 volt. That is the gain. It is represented by A. That value depends upon the resistors R1 and R2. So the output voltage V out is minus A into V in. This A is R2 by R1. Here already minus is represented. So here this is A to R2 by R1. And now this value is R2 by R1. And now the output is an inverted amplified version of the input. Next we move on to non-inverting amplifier. So in non-inverting amplifier means just the output is amplified but it is not inverted, that is in phase. The output is in phase with the voltage. Here it is a non-inverting, so V in is connected to the non-inverting terminal plus. So here input voltage V in has to be connected to the non-inverting input terminal plus, minus the same thing, it is grounded through a resistor. The feedback resistor is also connected. The feedback resistor is R2 and R1. So here you see the input signal is the blue color V in, and here the V out is the amplified one, but here it is not inverted, it is in phase. So the non-inverting amplifier means it is an op-amp circuit which produces amplified output signal. So here this output voltage equation is A into V in. This is the magnitude. This A depends on the value of R2 and R1. So the value of A is 1 plus R2 by R1. Next we move on to a differentiator circuit. So differentiator circuit means here the output is the differentiated value of the input, and what you are giving as input, the differentiated value will be the output. For that you need a capacitor in series with the source voltage. Now here the positive is grounded. Here a capacitor is connected in the source voltage. This is VI input voltage. A feedback resistor R is connected. And now you see here this is the input voltage given. And see, this is a sine wave. And then while differentiating the input voltage, differentiation of sine is cos. So in the output you are getting the cos wave and also an amplification. So differentiation of sine, it is cos. So sine 0 is 0, so it starts from 0. Here in cos 0 is 1, so it starts from the 1 value. So you are getting this output sine. So here output you are getting cosine wave. So the differentiator is also, it is also an inverting amplifier, since we are connecting the inverting terminal. So which uses capacitor in series with the input voltage. Here the output voltage amplitude is proportional to the rate of change of the input voltage, that is the differentiator. The last one is the integrator circuit. So here also the output is the integrated input. Here the capacitor is used as a feedback element. Here also the input terminal is connected to the inverting input terminal in series with resistor R. So here this also performs the mathematical operation. Here the output value changes to the input value over time. So here we have taken the input signal as a square wave. While integrating square wave, we are getting one triangular wave. And how we are getting means, here if it is a constant value means integration. So for example, if I will take it as 2, integration of 2 will be 2 into t. That means here you will get t, 2 into t, one slope is present. So here the V out voltage is minus 1 by RC integral V in dt. So the gain value is minus 1 by RC negative. So it is decreasing slope. Similarly here if you are applying negative voltage, gain also 1 minus, so positive slope. So for that you are getting a triangular wave. While integrating an input signal, you will get one triangular output signal. And here, so the op-amp integrator produces one output voltage which is proportional to the integral of this input voltage. So the output voltage V out is equal to minus 1 by RC integral V in dt. Thank you.